Hello, my dear students. How are you? Namaste to all. Today I am giving you very interesting chapter, that is oxidation and reduction. If you know oxidation and reduction, you can cover 50% of the chemistry. So that is very important for knowledge as well as examination viewpoint. So what you see, classical and modern concept of oxidation and reduction. So that is very important chapter for what you see, understanding, for knowledge as well as examination viewpoint. So at first, classical concept, that is also known as very old concept, yes, of oxidation and reduction. So according to classical and what you see, very old concept, oxidation it is defined, it is chemical, better to say, it is chemical process in which there is first one, addition of oxygen. So always keep in mind when you talk about the oxidation, so it is chemical process in which there is addition of oxygen atom. For example, so when you talk about what you say, carbon plus oxygen, when burnt in air, you are burnt in air, so what you get? CO2. So what you see? In this case, what you get? Just addition of carbon and oxygen. So where there is addition of oxygen, what you get? Oxidation. Likewise, when you talk about the copper plus what you say, oxygen. So when heated, so what you get? Cupric oxide, that is cupric oxide. So in this case also, what do we see over here? So in this case, addition of oxygen. In this also, what do we see? Addition of oxygen. So where there is addition of oxygen, always keep in mind there is oxidation process. Yes. Next one is second one is removal of hydrogen atom. For example, so we talk. So what's removal of what you say, hydrogen atoms? When zinc, granulated zinc is treated with what you say, dilute HCl, what to get? Zinc chloride plus hydrogen gas. What you see? 2Cl2. So simple heat and trial method. So that is Zn. Zn means zinc. So when zinc is treated with HCl, so what you get? There is formation of hydrogens. So zinc removes hydrogen from HCl, and what you get? Zinc chloride plus hydrogen. Likewise, when you talk about H2S plus Cl2, hydrogen sulfide and chlorine. So what we have? HCl plus what you say, sulfur. This arrow indicating downward means what do you see? Deposition of sulfur. So what do you see over here? So this chlorine removes hydrogen from S to S, and what you get? HCl. And what the next product? Sulfur. And this arrow indicating downward, it shows what you see? Deposition of sulfur over here. Yes. So the second point is removal of what you say? Hydrogen. Third one is what you say? C. Increasement in the valency of electropositive element, or we can say radical. You know about the radicals. Yes, group of atoms contains maybe positive and negative charge. So for example is like this. So suppose when say ferrous chloride, that is ferrous chloride is reacted with chlorine and heated. So what you get? Ferrichloride, that is known as ferrichloride. Yes. So in this case, charge of what you say iron is +2. Why? Because in this case, what is 2 chlorine atom. In this case, valency of what you see iron is how much? +3. +3, that is +3, that is +2. So what do you see? The charge of iron in this case is +2, but in this case +3. So what do you see? Increasement in the valency of electropositive. Iron is electropositive. Likewise, when you talk about what to say? Stannous chloride, SnCl2, that is known as stannous chloride. So when stannous chloride is treated with chlorine, when heated, so what we have? SnCl4, that is known as stannic chloride. So in this case, valency of tin is +2. In this case, valency of tin is what you see? +2. Better to say stannous has +2. In this case, what you see? +4. So what do you see? So there is increasement in the valency of electropositive element, or you can say radical. So where there is increasement in the valency of electropositive radical, there is oxidation. So these 3 points are very, very important. So always we have to keep in mind. But fourth one is rarely, not so common. Fourth point is what to say? D. What you see? Removal of electropositive element, or you can say radical. That is rarely. What do you mean by rarely? It means exceptionally, not so common. So when you talk about what you say, element like potassium iodide. This is potassium iodide. When that is treated with hydrogen peroxide, that is hydrogen peroxide. Yes. So what we have? Potassium hydroxide plus what you see? I2. In this case, what you see? So hydrogen peroxide removes, that is the electropositive, that is the electronegative. So removes what you see? Potassium from potassium iodide, and what you get? Potassium hydroxide. Also we can say in this case, hydrogen peroxide removes iodine from potassium iodide. So what we have? free iodine over here. So that is rarely, not so common. So when we talk about the what we see classical concept of oxidation, so always we have to keep 4 points. First one is addition of oxygen. Second one is removal of hydrogen. Third one is increasement in the valence of electropositive element. So these three are very important. But fourth one is what's rarely, not so common. Yes. So that is about the oxidation. Next one is reduction. Reduction. So it is a chemical process in which it is just reverse of oxidation. Yes, just reverse of oxidation. So what do you see? First point. First point is A. So in oxidation, what do you see? Addition of oxygen. So in this case, removal of oxygen. For example, so when you take very simple example like cupric oxide, that is cupric oxide. So when hydrogen is passed over this cupric oxide, so must be heated, otherwise no reaction over here. Heated. So process is what you see reduction. And what you get? Copper metal plus what you see? H2. So what you see over here? So hydrogen removes oxygen from copper, and what we have? Copper, and this arrow indicating downward shows so metallic copper over here. Likewise, when you talk about lead oxide, that is lead, it must be also heated. So when carbon monoxide gas is passed over, so process is reduction, and what you get? Pb plus what you get? Carbon dioxide. Yes. So what you see? This oxygen is removed by carbon monoxide, and what we have? Metallic lead. Metallic lead over here. So first one is removal of oxygen over here. Yes. First point. Second point is, in this case, oxidation, what we get? Removal of hydrogen. But in this case, what we see? Addition of hydrogen. Just reverse. Addition of hydrogen atom. Yes. So what we see? So we take very simple example like this. So we take very simple example like addition of hydrogen. When we talk H2 plus what to say? Yes, sulfur. So what we get? Hydrogen sulfide. That is hydrogen sulfide. So what is it? Addition of sulfur over here. Sorry, hydrogen over here. Like this, hydrogen when treated with hydrogen iodine. So what you get? Hydrogen iodide. In this case also what do you see? Just addition of hydrogen. So just reverse of oxidation we can say. B. Now third one is in oxidation what we observe? What we say? Increasement in the valency. But in this case what we see? Decreasement. All are reverse. Decreasement in the valency of electropositive element, or we can say radical. So look at over here example. So for example, what you see? When you talk about what you see ferric, that is ferric chloride. That is ferric chloride, when that is treated with the hydrogen sulfide, so what do you see? We get ferrous chloride, HCl and sulfur. Arrow indicating downward means deposition. So, in this case +3, in this case +2. So, what do you see? Decreasement in the valence from +3 to +2. Likewise, when we talk about that is stanic chloride, when that is treated with hydrogen sulfide, so what you get? Stannous chloride, HCl plus sulfur, that is stannous chloride. So, in this case +4 valency. In this case, what you see? Valency is +2. So, what you see? Decreasement of valency +4 to 2, +3 to 2. So, where there is decreasement in the valency of electropositive element or radical, we can say what you see? Reduction. Fourth point is rarely, not so common in both cases. So, first 3 points are very important, but fourth point is not so important. So, what you see in this case? Increasement in the number of electro positive example. For example, so when you talk about the example of this ones, what we see over here? So, what we see over here, example is increasement. So, what you see? When cupric, that is known as cupric chloride, yes, when it is heated with copper, so what you get? Cuprous chloride, that is cuprous chloride. So, how many copper atom out? 1, but in this case how much? 2 copper atom. Likewise, when you talk about mercuric chloride, when that is treated with mercury, so what you get? Ag2Cl2, so that is known as mercurous chloride. So, in this case 1 mercury atom Hg, but in this case how many? 2 mercury atom. Yes. So, when we talk about the reduction, what we see in classical definition? First one is removal of oxygen. Second one is removal of addition of hydrogen. Third one is decreasement in the valency of electropositive radical element, we can say. And fourth one is rarely, not so common. That is rarely, exceptional, you can say. Yes. So, that is about the classical definition of what we see? Concept of, or very old concept of oxidation and reduction. Now, next one is modern or electrolytic concept of oxidation and reduction. So, that is very important. Nowadays, generally we talk about the modern or what you see electrolytic concept of oxidation and reduction. So, first one is oxidation. So, what you see over here? So, in this it is a chemical, better to say it is chemical process in which there is loss loss of electron, consequently, as a result, consequently, 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 there is increasement in the valency of electropositive element, or we can say radical. Yes, very, very modern concept in this case. So what we see over here, when you talk, so what you see, ferrous, for example, that is ferrous ion. That is ferrous ion. So when it loses means loses one electron. So process is oxidation, and what we have, ferric ion, that is known as ferric ion. Yes. So in this case +2, but in this case +3. So in this case loses only one electron. So what we have, one positive charge. If loses two electrons, so what do you see, two positive charge. Yes. Likewise, when you talk about stannous ion, when it loses two electrons, oxidation. So what we have, stannic, that is known as stannic. Yes, it loses two electrons. So how much it has? Towards 4 positive charge. Likewise, when you talk about 2Cl minus chloride ion, when it loses two electrons, what we have? Process is oxidation, and what you get? Neutral. And after formation of neutral, what you get? Chlorine gas. Arrow indicating upward, it shows evolving of gas. So in this case, what we see? Loss of electron. Sometimes loses one electron, sometimes loses two electrons, sometimes loses three electrons. It depends upon the nature of the element. Yes. So that is about the oxidation, and that is also known as, this is also known as, what we say, oxidation is known as it is also known as de-electronation reaction. Why? Because D means loss of electrons. So that is also known as de-electronation reactions. Always keep in mind. So when talk about the oxidation, next one is reduction. That is, so what we see in this case, in reduction, that is also known as electronation reaction. Why? Because in this case, gain of electron. So what do you see? It is a chemical process. It is a chemical process in which there is gain, just reverse of oxidation, gain of electron. Consequently, we can say, consequently there is decreasement in the valency of positive element, or we can say radical. We can say radical. So what we see? In this case, gain of electron. But in oxidation, what we see? Loss of electron. So what we see when talk about the ferric, that is ferric ion. That is a very simple example. So when add one electron, you gain one electron, process is reduction. So when it gains one electron, one of the proton is cancelled neutral by these electrons. So what we have? That is ferrous ion. That is ferrous ion. Likewise, when you talk about first example, second example is like this. That is stannic ion. When it gains two electrons in short, process is reduction. So when two electrons is added over here, so two protons cancel out, and what we have? Two positive charge. That is known as stannous ion. Likewise, when you talk about the sodium ion, monovalent ion, when it gains one electron, its positive charge is cancelled, and what you get? Neutral. That is the neutral sodium metal. Yes. So according to oxidation, when we talk about oxidation, in modern concept, what we see? There is always loss of electron. Consequently, there is increasement in the balance of electropositive element. But when we talk about the reduction, that is also known as electronation, gain of electron, and what we get? There is decreasement in the balance of the what we see? Electropositive element. So always we have to keep this in mind. So what we see? Modern concept nowadays, modern concept of or electronic concept is generally asked in the examination. But also for the knowledge also we need classical knowledge. So in this case, sometimes ask you what is oxidation, what is electronation, what is de-electronation, give suitable example. Yes, what is the classical concept, give the suitable example. So yes, so thank you for watching this interesting video, and I think you have already subscribed it, and also convey your friends to better to say for learning. Yes, thank you all.